In this video, we are continuing our midterm 1 review and doing some limit examples. So I want to begin with a practice problem. Let's evaluate the limit as x approaches 3 of 3 minus x squared over 3 minus x. So I want to give you all a chance to try this problem first. So pause the video for 2 minutes to try this. That's going to be a recurring theme with all of these midterm review questions. Super important to pause the video and try these. So 4, 3, 2, 1, pause the video. Pause the video for 2 minutes to try this question. This would be a great midterm practice problem. All right, so hopefully you've done that. Hopefully you paused the video for about 2 minutes to try this. So the first thing that we do typically with a limit problem is we try plugging in. If we plug 3 in, we get 3 minus 3 squared over 3 minus 3, which is negative 6 on the top and 0 on the bottom. So overall, we have something of the form non-zero on the top and 0 on the bottom. And when we have something like that, our strategy is to take the one-sided limits. Okay. And technically, when we write the 0 on the bottom, it doesn't mean that it's exactly 0. It means it's really, really close to 0, because x is not exactly 3. When we talk about a limit, x is just getting really, really close to 3. Okay, so let's do these one-sided limits. So let's take the limit from the left first. So that'll be the limit as x approaches 3. I write a little negative sign in the exponent to indicate it's from the left. 3 minus x squared over 3 minus x. Okay, so there was no issue sort of plugging into the top. If I plug 3 into the top, we get negative 6. On the bottom, I have to be more careful and think about, is the bottom actually a little bit bigger than 0, so positive, or is it a little bit smaller than 0, which would mean it would be negative? All right, so if we take the fact that x is approaching 3 from the left and draw a number line and put 3 on it, so we are on the left side of 3, we're approaching it from the left, which means we're somewhere over here. And because of that, that means x is less than 3. And if x is less than 3 and I plug in a number that's smaller than 3, like 2.9 or 2.99 in for the x, that'll make my denominator get really close to 0, but it will be positive. And I indicate that by writing 0 with a little plus sign. That was our notation. Okay, so overall, I have a negative number on top, positive number on the bottom, because it's a little bit bigger than 0. So that's going to make this whole thing negative. And when you divide a number like, ignoring the negative sign now, because I've already put it there, when you divide a number like 6 by something really, really small, like 1 over a million or 1 over a billion, when you multiply by the reciprocal, it's going to be huge. So this ends up being an infinite type thing. And the negative I already written there. Okay, so the limit from the left is a negative infinity. The limit from the right is the limit as x approaches 3. I write a little plus sign to indicate from the right. So 3 minus x squared on top, 3 minus x on the bottom. And there's no issue with plugging in 3 into the top, so that gives me negative 6. But in the bottom, I have to be more careful. With the bottom, this time let's do it without the number line. If x is approaching 3 from the right, that means x is bigger than 3. And if you take a number bigger than 3 and you plug it in for the x, so something like 3.1 or 3.01, it makes the denominator get really close to 0, but it's negative now. So I put a little negative sign in the exponent. So overall, this is still going to be an infinite type thing, because you're dividing a number like 6, negative 6 technically, by something really, really small. And when you multiply by the reciprocal, it'll be huge. And then we have a negative on top, negative number on the bottom, because it's less than 0. So overall, that makes this positive. Okay. If you're a little bit unsure about, like, wait, why was this an infinite type thing? I discussed that in greater detail back in section 3.3 when we first talked about these algebraic limits. So that's a little bit confusing. I'd encourage you to look back at those videos. And if it's still unclear, then reach out and use our resources for help. Okay, so we've done these one-sided limits. That means our overall limit, the limit as x approaches 3, of 3 minus x squared over 3 minus x, because these are different, the one-sided limits, the overall limit does not exist. Does not exist, D&E, since the left and right, handed limits are different. And that's our answer here. The one-sided limits are different, so that means the overall limit does not exist. They have to be the same, and they have to be the same finite number for the limit to exist. All right, so let's do a couple of more practice problems, this time from the midterm review, midterm practice problems. So this is problem number 4, and I'm going to look at part F first. So we have the limit as x approaches 4 of this fraction minus this other fraction. So pause the video for about 2 to 3 minutes to try this one. 4, 3, 2, 1, pause the video. Pause the video for 2 to 3 minutes to try this question. All right, so hopefully you've done that. Hopefully you've paused the video for about 3 minutes to really try this. Even if you didn't finish the question, that's totally okay. I don't expect 3 minutes to be enough time to necessarily finish the problem. But really believe that the time that you're putting into this to practice these questions is going to help. Because the concepts that we're going to tackle in these problems are concepts that are going to be covered on the exam. Okay. All right, so our first step, the first step with a limit problem like this is we try to plug in. And if we do that, we end up with a 1 over 0 minus 8 over 16 minus 16, and that's 0. Okay, and also when I said before that the concepts that we're covering here are going to be in the exam, I don't necessarily mean like, oh, this example is going to be on the exam. What I mean is the concepts that we're going to be covering in the midterm review questions, which is in this video, limits. That is a concept that's going to appear on the exam. We cover that over the course of a whole chapter, so it's a really big concept. All right, so we have 1 over 0 minus 8 over 0. So looking at this, you know, if we just had like a non-zero thing over 0 on its own, not being subtracted by anything, we would do the one-sided limits. And the one-sided limits end up being either infinity or negative infinity. So each of these fractional things is some type of infinite thing, either positive infinity or negative infinity. And same thing with the second fractional thing. It's some type of infinite thing, either positive or negative, depending on which side I'm looking at. So it's like I'm taking an infinite thing and then subtracting an infinite thing. And that is one of our indeterminate forms. And with an indeterminate form, we simplify. That is our strategy. We have to simplify it first before we can plug in. Okay, so we have the limit as x approaches 4 of 1 over x minus 4. And we're subtracting two fractions. The way we subtract two fractions is we have to get a common denominator. So one thing that's going to help is if I factor this second denominator, it factors as x minus 4 times x plus 4. And seeing that, I only have to multiply the first fraction, top and bottom, by x plus 4. That's going to be enough to get a common denominator. I don't also need to multiply it by x minus 4 because there's already an x minus 4 there. Okay, so now doing the multiplication, we get the limit as x approaches 4. So 1 times x plus 4, that's x plus 4. And then that's going to be, we're going to subtract 8 from that. That's the numerator, all over x minus 4 times x plus 4. All right, so simplifying, we got the limit as x approaches 4. And on the top, we end up with x minus 4. And that's nice because the denominator is x minus 4 times x plus 4. That's nice because I noticed the x minus 4 on the top and on the bottom, they cancel. And after we cancel them, we get the limit as x approaches 4. On the top, we have 1. On the denominator, we have x plus 4. All right. Now we can plug in. So we get 1 on the top. On the bottom, we get 4 plus 4. And that is 1 over 8. And that's my limit. So this indeterminate form, this thing that was like infinity minus infinity, ended up being a finite number. It ended up being 1 over 8. So as a follow-up, I won't do this in the video, but I'd encourage you to do this on your own to get more practice with limits of this type. Try the following. I'm just changing one tiny number, changing the 8 to a 7, and see if that changes what the answer would be. This would be a really good follow-up to try. Okay, so I'm going to move on. I'm going to do another practice problem, but this follow-up would be a good one to try. All right, so the next problem I want to look at is part 4. This is 4 part G. So same number, 4, as we were looking at before, but part G. So pause the video for about 2 to 3 minutes again to try this problem. This would be another really good midterm practice problem. So 4, 3, 2, 1. Pause the video. Pause the video for 2 to 3 minutes to try this one. All right, so hopefully you paused the video. Let's go ahead and talk about this together. So first step is we want to try to plug in. If I plug in -2, we get -8 plus 8 on the top, -2 plus 2 on the bottom, which is 0 over 0. And 0 over 0, that's definitely an indeterminate form. And with an indeterminate form, just like we saw in the last example, our strategy is we simplify first. And when we say this is 0 over 0, that doesn't mean that the top is exactly 0 and the bottom is exactly 0. It just means that they're really close to 0. Okay, so how do we simplify this? So there's a formula I need to factor the top, and that is the sum of cubes. So sum of cubes, so let's review the sum of cubes formula. The sum of cubes formula is a cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. So that's sum of cubes. And just for review, let's also do difference of cubes, just for review, even though I don't need that one for this example. So there's a quick way to get difference of cubes if I know the sum of cubes formula already. All we do is we change the b to a negative b. So anywhere there's a b, let's replace it with negative b. And if we do that, we get a cubed plus changing the b to a negative b, we get negative b cubed equals, let's do the same thing on the right-hand side. We'd get a minus b times a squared minus a times negative b, because the b got changed to negative b, plus negative b squared. All right, so let's simplify this. This is a cubed minus b cubed on the left. On the right, we have a minus b times a squared. The double negative becomes a positive, so plus ab. And then when you square negative b, the negative goes away, because a negative times a negative is positive, so we get plus b squared. Okay, so sum of cubes is this formula right here. Difference of cubes, after we simplified it, is this formula right there. So I mentioned already, I kind of tipped my hand a little bit and said we want to use sum of cubes for the numerator, x cubed plus 8. So to do sum of cubes, I want to be able to write this as something cubed plus something cubed. So what goes in these parentheses? So what cubed ends up being x to the third? Well, it's x. I put x inside. X being cubed ends up being x to the third power. That one wasn't too bad. And then what cubed is 8? And that's 2. 2 cubed is 8. So from that, we can see that in terms of my general formula for sum of cubes, the first thing that's being cubed, so like my value of a in this problem is the x. So my value of a is x here. And then the value of b, so the second thing being cubed, is the 2. So we're going to use sum of cubes and factor x cubed plus 8. And when we do that, we get the right-hand side. Anywhere there's an a, we're going to write x. Anywhere there's a b, we're going to write 2. Okay, so all of this here was this is just a bit of review. And we ended up just using part of this to do our problem. So let's continue our limit. We get the limit as x approaches -2. Doing sum of cubes, we're going to get a plus b first. So that's x plus 2 once we plug in our values. Let me put a bubble around this. This was a bit of review right here, review bubble. X plus 2, then we get a squared, which is x squared, minus a times b, which is 2x, plus b squared. So 2 squared is 4. So that's what's the top factors in this. And the bottom is x plus 2. And from here, it's not too bad, because the x plus 2's cancel. And after we cancel them, we have the limit as x approaches -2, x squared minus 2x plus 4. All right. So now the thing that was stopping us from plugging in -2 before, because that made the denominator 0, that's gone. So we are good to plug in. The thing that made the indeterminate form is now gone. So we plug in, we get -2 squared minus 2 times -2 plus 4. So this is 4 plus 4 plus 4, which is 12. And that's our limit in this example. So in the next video, we will do some infinite limit questions.